It seems like nobody can stop talking about MCP. And with all the AI releases, new LLM developments every single day, it can be hard to figure out what is hype versus what is actually useful technology. MCP seems to have stuck though. We've seen tons of new startups and companies already adopting it, and it's only come out in November 2024. As someone who's been building AI apps since the launch of ChatGPT in late 2022, I know from firsthand experience how difficult it can be to give LLMs access to tools. Amidst all the hype from AI bros, I want to give you a practical overview of MCP, where it stands in the ecosystem, and my favorite MCP integrations that I use inside of Cursor. First of all, let me show you how I'm using MCP in my current Cursor workflow. So on the right here, I have my chat, and I asked my Cursor agent to fetch me the latest tasks. It thought for a second, and then it realized that we were using Taskmaster inside of our code base. And then it was able to call this MCP tool with these two parameters, read all of this information back about my to-do list, and then it interpreted those results and gave me a summary of what was going on in my project. To set this up, all you have to do is go into Cursor, add a new global MCP server, and define the JSON in a schema like this. You can add tools like Taskmaster, Supabase, and GitHub so that your Cursor agent will have access to these tools. You can then use Cursor rule files to help describe to your agent all of the tools that it has available to it and how it should use those tools. So in this case, I've always attached it in case the agent needs to update the to-do list. I don't always want to have to mention Taskmaster, but you can also manually attach this if you find that your agent is having trouble figuring out when to use that tool. All right, so now that you have a high-level picture of what MCP is doing, I want to describe why we even need something like this. So giving your LLMs access to your proprietary data, things like files, database, or other external APIs, was traditionally a very difficult thing that required a lot of development overhead. However, this was really useful for getting our LLM to get the most relevant context that might have been outside of its window. So whether it needed to do a Google search or fetch actual data in our database, this gave our LLM a way to call those functions and then read the responses to give us a more relevant answer. The OpenAI documentation gives a great example of this. And in this example, we can see that we have to describe a get weather function, all of its parameters and which ones are required. And then we give those tools in a separate parameter to the OpenAI completion so that OpenAI can request this tool call, and then we can run that function and pass the results back to OpenAI. I'm not going to go over function calling in detail in this video, although I do have a separate video on that. So for a couple functions, this might be okay. But when you start to have 10 or maybe even 50 function calls, your LLM is going to have a hard time figuring out which function to use, creating the arguments in the right format, and then also answering the user's request. By stuffing all of this information into the prompts, we're going to reduce the accuracy of all the tasks that we've asked the LLM to do. This is a problem for most AI applications because if your user requests the latest weather update, your LLM should be able to fetch the API 100% of the time without any of the errors. Additionally, every company has a different way of writing software. So in the AI ecosystem, we're seeing a huge lack of standardization across these integrations. At the end of the day, this is all about writing quality software so that our large language model will be able to produce the desired result for our user. But what if there was a different way to approach this? Well, that's where Anthropic's new Model Context Protocol, or MCP, comes in, which was released in November 2024. What MCP did for AI is similar to what USB-C did for hardware. Instead of needing a different cable for every device and having to create these custom integrations, this allows us to just develop using this MCP and hook up our integrations one by one. Before MCP, every AI model needed a custom connector for every new data source, which created a huge mess as the number of models and the tools grew. By using the MCP Model Context Protocol, it fixes this by giving a common language that the AI models can understand. Now, LLMs can use these data sources without having to stuff all of the context into the prompt. I think another great way to understand this is by thinking about the client-server protocol in building web applications. So you can notice here how we have the client, some sort of a standardized protocol, a server, and then data or tools. Each layer is separated nicely here so that even if we swap any one of these services, we can do so without affecting any of the other parts of our app. If we wanted to swap Next.js for React or Vue.js, we could do that as long as the new front end calls the same REST endpoints. Same thing goes for the server. If we wanted to swap the Supabase platform, which is the edge functions and the Postgres database in this case, for another backend stack like using Firebase, we would be able to do that because the REST contract stays the same. In this data flow, we have the front-end UI, which is going to request data from the server. In this case, we want to display the user's data in this blog panel component. To do that, we hit a fetch request, which calls this HTTPS endpoint. This is going to hit this endpoint over here, and then our edge function is going to process the limit requested by the user. It's going to process this into a JSON response and return that into our front end. Finally, we'll take that data and display it in the UI. Now that we understand it for web apps, we can extend this explanation to MCP servers. So if we start by saying something like, show me the latest 10 blog posts in natural language, our cursor agent is going to translate that sentence into a structured tool call or an MCP request. It generates the appropriate request parameters and then calls the Supabase MCP server to grab those user posts. In this case, it's going to hit the Supabase MCP server, which was written by the Supabase team. So there might be a function like this, which abstracts out the SQL and then is able to access our Supabase database. So this model context protocol is similar to the REST API in that we don't actually write it, it's developed by somebody else. And then now all the applications that use it are able to use that same standard protocol. This means that we have three authors here: the cursor agent, which is developed by the cursor team, the protocol spec that comes from Anthropic, and the server implementation that comes from the provider. So that could be hooking up to a Supabase, a Gmail, or a GitHub server so that we can access that kind of data. In both stacks, the client is going to rely on this stable contract so that it can connect to a server. Now, similar to Next.js being able to be swapped for Vue or React, we can use Cursor to swap this MCP agent with one from Windsurf. Another awesome thing about MCP is that it's fully open source. This is a strategic move from Anthropic in order to drive more integrations and therefore the usefulness for AI agents. This in turn will improve the usage for large language models like Claude, but the same goes for other LLMs like GPT-4o. Additionally, through the open source community, we're able to have so much more accelerated progress rather than if this were to stay as a R&D project within the smaller team in Anthropic. So MCP is a great tool, but what are its limitations? One of its current limitations is its lack of a standardized authentication system. The protocol itself doesn't specify how auth should be handled, so it's up to the implementers of these MCP servers to create their own solutions. So I think security best practices is a huge topic in current MCP servers. Additionally, there aren't that many MCP servers out yet, but we're seeing new ones pop out every day. The ones I currently use are the Supabase MCP server as well as the GitHub MCP server. All right, so now that we have a fundamental understanding of how the Cursor MCP agent works, let's set it up so that we can use Taskmaster as well as Supabase or GitHub or any other tool that supports MCP.